The difference between aerobic and anaerobic respiration is that anaerobic respiration is without oxygen, and it probably started first because the atmosphere didn't have oxygen in it at first, so organisms lived to survive without it. And there are lactic acid fermentation and alcoholic fermentation are two different ways that you can do this. Lactic acid fermentation starts with a pyruvate and an NADH, and it makes lactate and NAD+. And alcoholic fermentation starts with pyruvate and NADA and NADH. And it makes ethanol, CO2, and NAD+. NAD+ and FAD are electron carriers that move electrons through the electron transport chain and create a concentration gradient. Glycolysis happens in the cytoplasm, and it starts with ATP and glucose, and it makes 2 ATP and 2 pyruvate.
So the Krebs cycle starts with acetyl-CoA, which then combines with oxaloacetate to form citric acid. And then as you're going down here, it's reducing it by the NAD+, converting to NADH, which at the same time takes out a carbon and oxygen, making CO2. And that's going to happen a couple times over here to reduce it. And then we're also going to make ATP out of ADP from that. And then over here, FAD is going to take 2 hydrogens out to make FADH2. And more NAD plus is going to make NADH. And then we're getting back to the 4-carbon compound oxaloacetate that we need at the beginning. And this is going to happen twice, so we're going to get a net of 2 ATP and CO2. So electron transport is the next step after the Krebs cycle. And the Krebs cycle happened in the matrix, and this is going to happen on the inner membrane. So the NADH that we made over here now comes over here and deposits the electrons and becomes NAD plus again, which is just going to go back. The electrons move down and at the same time pump hydrogen ions into the inner membrane space from the matrix. And so now we're creating a chemical gradient over here. Now later down the line, FADH2 puts its electrons into the electron transport chain. Just like how it was made later in the Krebs cycle, it comes in later here, meaning it's going to produce less net ATP. So this hydrogen ion concentration we've built up in the inner membrane space is then going to diffuse through ATP synthase across the membrane back into the matrix and phosphorylate ADP to make ATP. And at the end of the electron transport chain, oxygen is going to be the final electron acceptor of this chain. And then hydrogens that are free-floating are going to combine with that, and we're going to get water. So like in photosynthesis, we broke down water into oxygen and hydrogens, and now we're putting it back together because it's essentially the opposite. The main differences between photosynthesis and cellular respiration is that photosynthesis is an anabolic pathway, meaning it's going to build molecules up, while the Krebs cycle and cellular respiration are an anabolic pathway, so they're going to be breaking down the products of photosynthesis into energy. And another main difference, like I already mentioned, is that in the electron transport chain we're going to be making water, whereas in photosynthesis, in the light reactions, we were breaking water down.